Hi, I'm Upasna from Edureka. Let's discuss what are the roles and responsibilities of a big data engineer and what makes it such an important profile. But before we begin, let's look at the agenda for today. So first up, we're going to discuss who is a big data engineer, followed by what does a big data engineer do. Then we are going to look at the highlight of this presentation, which is the big data engineer roles, followed by the responsibilities. And finally, we are going to be looking at the big data engineer skills that are required to fulfill those roles and responsibilities. So without much ado, let's get started. Now, who is a big data engineer? A big data engineer is somebody who is responsible for collecting the data from various sources, transforming it into a usable format and storing it. They basically take raw data and convert it into something that is optimum for stakeholders that access the data. It makes it easier to process and derive business insights from. Stakeholders can be data analysts, data scientists, and software developers. In simple words, data engineers transform data into a format which can be easily analyzed. In order to collect and store data, these professionals design, build, test, and maintain complete infrastructures. This system provides a foundation for each and every data-driven activity and action that is performed in the organization. And while doing so, big data engineers always keep the business requirements in mind. Now, let's look at the big data engineers' roles. Now, there are typically three kinds of roles that a big data engineer has to assume. First of all, we have the generalist. Now, generalists are typically found on small teams or in small companies. In this setting, data engineers wear many hats as of one of the few data-focused people in a company. Generalists are often responsible for each step of the data process, from managing data to analyze it. Next, we have pipeline-centric data engineers, often found in mid-sized companies. These engineers work alongside data scientists to help make use of data that they collect. Pipeline-centric data engineers need in-depth knowledge of distributed systems and computer science. And finally, we have the database-centric profile. In larger organizations where managing the flow of data is a full-time job, data engineers focus on analytics databases. Database-centric data engineers work with data warehouses across multiple databases and are responsible for developing table schemas. Now, the next logical question will obviously be, what does a big data engineer do? Now, a big data engineer plays a big role in any data-driven business, which also means they are responsible for many things. But most importantly, they are responsible for designing, creating, testing, and maintaining the complete infrastructure, and for storing and processing data that is gathered from various sources. In order to perform this activity, data engineers need to have a good grasp of fundamental knowledge such as OS, programming knowledge, and database management system. Apart from this, the professional has to be an expert in SQL development, further providing support to data and analytics in database design, data flow, and analysis activities. The position of the database engineer also plays a key role in development and deployment of innovative big data platforms and for advanced analytics and data processing. The next thing I want to talk about is building highly scalable, robust, and fault-tolerant systems. Now imagine a building. We all know that the deeper it is under the ground, the higher the building can be constructed without collapsing. Now, a big data engineer does something pretty similar with data. Now, these data engineers work closely with big data architects in designing a complete architecture. Both of them make sure that the system must be scalable in terms of either adding new data sources or in handling exponentially growing huge amounts of data. Big data engineers should also have the capability to architect highly scalable distributed systems using different open source tools. Designing consideration should incorporate that the system must be robust and fault tolerant, where each component should provide a level of fault tolerance. They are also involved in the design of big data solutions because of the experience they have with Hadoop-based technologies such as MapReduce, Hive, MongoDB, or Cassandra. A big data engineer builds large-scale data processing systems and is an expert on data warehousing solutions and should be able to work with the latest NoSQL database technologies. Next, let's talk about the biggest process in all these responsibilities, which is the ETL or the extract, transform, and load process. Mundane as it sounds, This is actually the process which might take the most amount of time. In order to store data in such a format that data analysts and data scientists can analyze and derive meaningful insights from it, the raw data collected from various sources need to be transformed. Data engineers need to have the knowledge of programming language and tools to perform ETL. The ETL process becomes much more complex when big data comes into picture. With the advent of huge amounts of data, which is getting generated at a very high rate, it becomes even more tough to perform ETL. A big data engineer should be somebody who does this with utmost proficiency. Next is the business acumen aspect. Now, data engineers should have a good business acumen so that the system that he or she develops or the data that is transformed and stored should be according to business needs. This reduces the cost of deriving insights from data, and a good data engineer performs half the transformation that is required for data analytics. Larger organizations often have multiple data analysts or scientists to help understand data, while smaller companies might rely on a data engineer to do so. Next is data acquisition. Now, data engineers should always look at the bigger picture. He or she must have the idea about gaining data from various sources and how the data helps in gaining insights. This will help him or her to understand how data is acquired from different sources and can be used in different ways to derive insights from. They can also try finding more data sources that can help getting more accurate predictions and better insights. Next, let's talk about the programming languages and tools that a data engineer should be proficient in. Some of the responsibilities of a data engineer include improving data foundational procedures, integrating new data management technologies and software into existing systems, and building data collection pipelines. A big data engineer should embrace the challenge of dealing with petabytes or even exabytes of data on a daily basis. A professional so understands how to apply technologies to solve big data problems and to develop innovative big data solutions. In order to be able to do this, the big data engineer should have extensive knowledge in different programming or scripting languages like Java, Linux, Ruby, Python, or R. Also, expert knowledge should be present regarding different NoSQL or relational database management systems such as MongoDB or Redis. Building data processing systems with Hadoop and Hive using Java or Python should be common knowledge also to a big data engineer. Apart from this, he or she should have a good command over at least one programming language and multiple tools. Knowledge of ETL tools and data warehousing tools is also required. Apart from the knowledge of individual tools, big data engineers should also know how to integrate various tools and create a complete solution based on given requirement. Now, having said all that, one very important thing which a data engineer should be looking at is performance tuning. One of their responsibilities includes performance tuning and making the whole system more efficient with time. First, the performance of an individual component needs to be improved, and then the entire system needs to be optimized. With that, let's move on to the summary of what we've discussed so far in terms of responsibility. Now, with all that said, the basic responsibilities of a big data engineer boils down to these three things. First up, data ingestion. Now, this is associated with the task of getting data out of the source systems and ingesting it into a data lake. A data engineer should need to know how to efficiently extract data from a source, including multiple approaches for both batch and real time. Apart from these, they would also need to know about how to deal with issues around incremental data loading, fitting within small source windows and parallelization of loading data as well. A part of it is also data synchronization, which could be considered a subtask of data ingestion, is data synchronization. But because it is such a big issue in the big data world, since Hadoop and other big data platforms do not support incremental loading of data, here the data engineer should need to know how to deal with changes in source data, merge and sync change data from sources into a big data environment. Next, let's talk about data transformation. This is the T part in the ETL, which is extract, transform, and load, and is mostly focused on integrating and transforming data for a specific use. The major skill set here is knowledge of SQL, and as it turns out, not much has changed in terms of the type of data transformations that people are doing now, as compared to a purely relational environment. Finally, performance optimization, and data models. Now, this is one of the tougher areas. Anyone can build a slow-performing system. The challenge is to build data pipelines that are both scalable and efficient. So the ability and understanding of how to optimize the performance of an individual data pipeline and the overall system are at a higher level of data engineering skill. For example, big data platforms continue to be challenging with regard to query performance and have added complexity to a data engineer's job. In order to optimize performance of queries and the creation of reports and interactive dashboards, the data engineer needs to know how to denormalize, partition, and index data models, or understand tools and concepts regarding in-memory models and OLAP cubes. Now that we've spoken about the responsibilities of a data engineer, let's talk about the skills that is required to assume these responsibilities. These are the basic skills that one should have to fulfill the responsibilities of a big data engineer. First of all, let's talk about big data frameworks or Hadoop-based technologies. Now, with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing a framework which not only stores big data in a distributed manner, but also processes the data parallelly. There are several tools in the Hadoop ecosystem which caters to different purposes and professionals belonging to different backgrounds, but some of the tools which are must to master are HDFS or Hadoop Distributed File System, which as the name suggests is the storage part of Hadoop, which stores data in a distributed cluster. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with this framework. Next we have Yarn, which was introduced originally in Hadoop 2.x in order to make Hadoop more flexible, efficient, and scalable. Yarn performs resource management by allocating resources to different applications and scheduling jobs. Next, we have MapReduce, which is a parallel processing paradigm allowing data to be processed parallelly on top of distributed Hadoop storage. Next, we have Pig and Hive, which look at the data warehousing perspective of big data to perform analytics and scripting. Next, we have Flume and Scoop, which are popular tools for importing and exporting data to HDFS. Next, we have Zookeeper, which acts as a coordinator amongst the distributed services running in the Hadoop environment. It also helps in configuration management and synchronizing services. And finally, we have Oozie, which is a scheduler binding multiple logical jobs together and helping in accomplishing a complete task. The next skill I'm going to talk about is real-time processing framework. Now, real-time processing with quick actions is the need of hour. Either it is to detect fraudulent transactions in a credit card system or a recommendation system. Each and every one of them needs real-time processing, and it is a very important skill for a data engineer to have. Now, Apache Spark is one such distributed real-time processing framework which is used in the industry rigorously, and it can be easily integrated with Hadoop leveraging HDFS. Next, database management systems and architecture. A database management system is something that stores, organizes, and manages a large amount of information within a single software application. Data engineers need to understand DBMS to manage data efficiently and allow users to perform multiple tasks with ease. This will help the data engineer in improved data sharing, data security, access, integration, and minimize data inconsistencies. These are fundamentals that said professional should know to build a scalable, robust, and fault-tolerant system. Next, we have SQL-based technologies. Now, there are various relational databases that are used in the industry such as Oracle DB, MySQL, Microsoft SQL Server, SQLite, etc. Now, data engineers must have at least the knowledge of one such database. Knowledge of SQL is also a must. Structured query languages is used to structure, manipulate, and manage data stored in relational bases. As data engineers work closely with relational databases, they need to have a strong command on SQL. Next, we have NoSQL technologies. As the requirements of organizations had grown beyond structured data, NoSQL databases were introduced. It could store large volumes of structured, semi-structured, and unstructured data with quick iteration and agile structure as per application requirements. Some of the most prominently used databases are HBase, Cassandra, and MongoDB. Next, we have programming languages. Now, various programming languages can serve the same purpose, The knowledge of just one programming language is enough, as the flavor changes but the logic remains the same. If you're a beginner, you can go ahead with Python as it is easy to learn due to its easy syntax and good community support, whereas R has a steep learning curve which is developed by statisticians. Now R is mostly used by analysts and data scientists. Next we have ETL or data warehousing solutions. Data warehousing, which is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply ETL. Now data warehouse is used for data analytics and reporting and is a very crucial part of business intelligence. It is important for a big data engineer to master one data warehousing or ETL tool, and after mastering one, it becomes easy to learn new tools as the fundamentals remain the same. Informatica, ClickView, and Talend are very well-known tools used in the industry. I would recommend you start with Talend because after this, learning any data warehousing tool will become a piece of cake for you. And finally, we have operating systems. Apart from all these skills, intimate knowledge of Unix, Linux, and Solaris is very helpful, as many math tools are going to be based on these systems due to their unique demands for root access to hardware and OS functionality above and beyond that of Microsoft's Windows or Mac OS. That was all about the skills. With that, I conclude my session. Thank you and have a great day ahead.